In this tutorial, we're going to take a look at some examples of solving linear equations. And the first one is 5x minus 4 equals 31. And what this equation means is there's some unknown number that we've multiplied by 5 and then subtracted 4, and you get 31. So in order to find what x is, we kind of work backwards from that. And so that's why I want to get the 5x term by itself, or it's called isolated, okay, alone on one side. And so that's why we would add 4 to both sides first here. And that's because there's a minus 4 here. So what that adding 4 does is it gets the 5x all by itself isolated on the left. And on the right, we would add 31 and 4 to get 35. Now, so this means 5 times some number is 35. Well, I don't want to know what 5 times the number is. I want to know what the number is. So the opposite of multiplying that x by 5 is to divide out the 5. So we divide both sides by 5. And these 5s over here are said to divide out or cancel. 5 divided by 5 is 1. So that's why it just simplifies to x on the left here. And 35 divided by 5 is 7. So the answer would be 7. Now you can always check any equation by seeing if 7 makes the original equation to have the same value on both sides. So you see on the left, it's 5 times 7, because I think x is 7, 5 times 7 minus 4. So that does give a value of 31. There's nothing to evaluate on the right side because there was originally just a 31 there. So that is the number that makes that a true statement, and that's why that's called the solution. You see, if you made a mistake, and let's say you thought the answer was negative 2, for example. If I put negative 2 in there and then minus 4, well, it doesn't work out to the 31 over here. So 7 is the only number that makes it equal to 31, and so that's why 7 is the only answer. Okay, second one here, well actually we'll look down here. B first, we'll go to C, the third. So negative 2 times x minus 3 equals negative 7. Now a normal thing to do first here is to distribute or multiply the negative 2 into the brackets here. And so that's what I'm going to do first here. I'm going to multiply the negative 2 in here. And so negative 2 times x would be negative 2x. And then after that, I'll multiply the negative 2 in by the other term, the negative 3 in there, which of course is 6. Negative time, remember we've got a negative times a negative, that's a positive, that's why, so it's plus 6. And that equals the negative 7 on the right here. So now it's a very similar question to A. I want to get now the term that has the x alone, so I will want to get rid of the 6 here. I want to isolate the negative 2x first. So the opposite of adding 6 is to subtract 6. So we'll subtract 6 from both sides. Remember, you got to do the same thing to both sides always. And so this is 0 right here, so we just have the negative 2x on the left. And negative 7, take away 6 on the right, would be negative 13. So we're at negative 13 there. Now, this says negative 2 times our unknown number is negative 13. Well, I don't want to know what negative 2 times the number is. I want to know what the number is. So to get rid of that negative 2, since it's multiplied by the x right now, we would divide both sides by negative 2. And again, the idea is that these negative 2's divide out over here. Like that. See, negative 2 divided by negative 2 is 1, so they're gone. And so we just left with x on the left, and negative 13 divided by negative 2 is 6.5. So 6.5 would be the answer for this one. And if I wanted to check it, I could go negative 2 times in brackets. I'll put my 6.5 right there. So 6.5 minus 3, and it should equal negative 7. And it does, so that's why 6.5 is the correct answer. Now C here. W over 8 minus 7 equals negative 3. So the last two has some fractions or fraction parts in them. And so this is actually a lot like the first two. If we've got this term with a variable in it, and then minus 7, see there's like a minus 4, there's over here like this is a plus 6, and there's a number on the other side. So very similar to A and B, I want to get the W over 8 alone or isolated first, so I want to get rid of the negative 7. See, I don't really want a number on this side and a number on that side, so that's why I want to, and you'll hear some teachers say bring the negative 7 over. What you're actually doing is the opposite of subtracting 7, which is adding 7 to both sides. So those add to 0, so that's why there's just a w over 8 on the left here. And negative 3 plus 7, of course, is 4. That's the same as 7 take away 3, so that's 4. Now this says w divided by 8 is 4. I don't want to know what w divided by 8 is, I want to know what w is. So see, the w is divided by 8, so the opposite of dividing by 8 is to multiply by 8. So multiply by 8 on both sides, and these 8s divide out. 8 divided by 8 is 1. So that's why that just gives you a w on the left here. And 4 times 8 is 32. So that would be our solution. And again, you can check. So if I put 32 in here, if I go 32 divided by 8 and then subtract the 7, minus 7, see, I should get negative 3. And I do, because you see, that's actually 4 take away 7 gives you the negative 3. So that would be the solution. And again, if I made a mistake and, maybe I made some error and I thought that w was 50. See, if I put 50 in place of w here, 50 divided by 8, and then minus that 7, I do not get the negative 3. I get something else. So that would not be a solution for that one. Okay, last one here, and it's just a little longer. It's still got some fraction parts to it. Now, I've kind of spaced it out here because I want to multiply both sides by a number so that the denominators divide out like the 8 did here. And there's actually two denominators here, 2 and 3, and some questions you might have a third one or a fourth one. What you want to do is multiply everything on both sides, all three of these parts, by a number that 2 and 3 both divide evenly into. And if you don't know what that, it's called the least common multiple is, what you can do is list the multiples of 2 and 3. So I'm going to just write that down here so it's not in the way. See, the multiples of 2 are 2, 4, 6, 8, 10. I'll just list the first 5, ... And the multiples of 3 are 3, 6, 9, 12. That's lots. I don't need any more than that. And see, the least common multiple is the first number that appears in both lists. So that's the smallest number that 2 goes into and 3 goes into evenly. So that's why I'm going to multiply everything on both sides by 6. Now, the reason for that is so these denominators divide and I get rid of my fractions. That's the reason for that. Now, because this 6 is being multiplied by this whole thing here, it's a good idea to actually put brackets around that x plus 13 on top, because there's two different terms there. Because somebody might look and think that they only multiply the x by that number, but they multiply both terms. And the same thing over here, I'll put brackets around that binomial as well. I don't really need to do the 1. I mean, I could put brackets around the 1, but I don't really need to because there's just one term there. Now, again, the idea of the dividing by 6, or sorry, multiplying by 6, is so the denominators, the bottoms, the fractions divide out. See, this 2 goes into 6 3 times. So what I have here now is 3 times this x plus 13. So we'll write that down below. And 6 times 1 is 6, so we'll just write 6 there. There's nothing to divide it there, it's just 6 times 1. And then over here, 3 goes into 6 twice. So we have 2 times this 2x plus 35 over here. And so now, it's actually quite a bit like b. It's a little longer, but we have like a number times a binomial, same idea here. And the next thing I want to do is start expanding. So I would go 3 times the x, and that's 3x. And then I would multiply the 3 by the 13, and that's 39, so plus 39. And then the 6 is just, we just leave the 6 there. And then the 2 times the 2x would be 4x. And then the 2 times the 35 gives the 70 here. Now, similar to the previous ones, I want to get the x's alone on one side and the numbers on the other. This is the first one where we've had 2 different x's, one on each side, okay, and more than one number. There's a couple here over here. So let's bring all the x's to the left and the numbers to the right. Now, the way I get rid of the 39 and 6, you see they're both added to the 3x. So I'm going to subtract 39 and 6 both. Okay, and you see this, see that adds to 0, and that adds to 0. And so on the left here, I just are left with 3x. Now over here, we have the 4x, and now we want to actually just do the arithmetic. So we would take 70, and subtract the 39, and subtract the 6. And so that's where the 25 comes from. So now I want to get the x's together on the same side. See, I got the numbers, just one number here. So I'm going to bring the 4x over here to the left side. So see, it's a positive 4x. So the way I would do that is I would subtract 4x on both sides. Some people say, well, bring it over and it changes its sign, and that's really the same thing. That's kind of a shortcut. So those add to 0, and on the left here, 3x minus 4x is negative 1x, or just negative x, and we have just 25 on the right. Now that negative x is the same as negative 1x, so the way we isolate for x and get rid of the negative is we divide both sides by negative 1. So just like that, so we divide out the negative 1, and you see there's really a negative 1 here. That divides out with that negative up there, and so we get x equals negative 25. And again, we could check that one last time. So again, look at, that's why I color coded these so you can see the original equation. So I'm going to put negative 25 in here. So negative 25 plus 13. So negative 25 plus 13 bracket divided by the 2 and then plus the 1. Divided by 2 plus 1. So the value on the left side is negative 5. So if I put the negative 25 in here and I get negative 5, well, we're good. So over here, so we go 2 times that negative 25 plus the 35, plus 35. And I'll close my bracket so it evaluates all that before I divide out the 3. And divide it by 3. I do get the same number, so that checks that the negative 25 is the correct solution. And that's the end of the tutorial.